In this video, I want to do some examples of word problems that involve solving rational equations. Now, these examples in this video, I'm going to call proportion type examples, and you'll see why in just a second. This problem says it's recommended that 7.7 milliliters of plant food be mixed with 2 liters of water for feeding houseplants. How much plant food should be mixed with 1 gallon of water to maintain the same concentration? And we're told that 1 gallon is equal to 3.8 liters. And we need to express our answer in milliliters. And we're going to round to 2 decimal places if necessary. I call these proportion examples because we're going to be able to solve these questions or solve these problems using proportions. But if we're going to solve a problem using a proportion, we must always be given one side of the proportion. Or I like to say that we must be given a ratio of comparison. In this problem, we're given the ratio of 7.7 milliliters of plant food to 2 liters of water. That's going to be the left side of our equation. That is our ratio of comparison. For every 7.7 milliliters of plant food, we need to mix with that 2 liters of water. And mathematically, we can express that ratio like this: 7.7 milliliters. So that numerator represents the amount of plant food over 2 liters. And the denominator here represents the amount of water. And the question is, how much plant food should I mix with 1 gallon of water to maintain the same concentration? So this 7.7 over 2 has to be equal to something. And on the right side, we're going to have another fraction or another ratio. And because we set up the left side of this equation with plant food in the numerator and the amount of water in the denominator, we have to set up the right side the same way. The amount of plant food over the amount of water. Now, had I set this problem up initially as water over plant food on the left, in other words, 2 over 7.7 on the left, that would have been fine too, as long as I do water over plant food on the right. We have to be consistent. So in this case, I did plant food over water on the left, so I have to do plant food over water on the right. And the question is, how much plant food? Well, obviously, that means that we're looking for the amount of plant food. So I'm going to let that be x. The amount of plant food goes in the numerator. So x goes in the numerator. And in the denominator, I need the amount of water. Well, I'm told that I want to mix this certain amount of plant food with 1 gallon of water. Well, on the left, our water is listed in units of liters. So on the right, our water has to be in liters as well. In other words, when I'm solving these types of problems, I can't mix my units. If the left fraction or the left side of this equation is in milliliters over liters, then the right side has to be in milliliters over liters as well. And the good news is that we're told that 1 gallon is equal to 3.8 liters. So the amount of water that I want to mix on the right is 3.8 liters. Because this is a proportion with one unknown, we can solve it by cross multiplying. Now, if you're not sure how to solve by cross multiplying, make sure you go back and watch the video on solving proportions. To solve an equation by cross multiplying, we have to have one fraction equals one fraction. This won't work in any other situation. The good news is that we do have one fraction equals one fraction. To solve by cross multiplying, we multiply the numerator on the left to the denominator on the right. So 7.7 times 3.8 will be our first cross product. And that cross product has to be equal to the next cross product, which will be 2 times x. So we have 7.7 times 3.8 on the left equals 2x. Now we solve for x. Let's simplify the left side by multiplying 7.7 by 3.8. That gives us 29.26. And now we divide both sides by 2 to solve for x. So we find that x is equal to 14.63. Now remember, x is the amount of plant food. And what were the units that our plant food was measured in? Milliliters. So the x must be 14.63 milliliters. So to maintain the recommended concentration of plant food to water, we would need to mix 14.63 milliliters of plant food with 3.8 liters, or 1 gallon, of water. This example says cooking oatmeal requires 1 cup of water for every half a cup of oats. How many cups of water will be required for 4/5 cups of oats? We can set up a proportion here because we know every 1 cup of water we have to have half a cup of oats. That's our given ratio. And this has to be equal to, on the right side, another ratio. And because we set up the left side as water over oats, we have to set up the right side as water over oats. And we're looking for the number of cups of water. So in this case, we'll let X be equal to the number of cups of water that we need to mix with these oats. And we're told how many cups of oats we're using, 4/5. So now we have our proportion. 1 cup of water over half a cup of oats has to be equal to X cups of water over 4/5 cups of oats. And again, because this is a proportion, one fraction equals another fraction, we can solve this equation by cross multiplying. The first cross product will be 1 times 4/5, which is 4/5. And that has to be equal to the second cross product, 1/2 times x, or 1/2 x. Now let's solve for x. Multiply both sides of the equation by 2. On the left, 4/5 times 2 gives us 8/5. And on the right, 1/2 x times 2 gives us x. So we find that x is equal to 8/5. Now remember, x was the number of cups of water that we would need to mix with 4/5 of a cup of oats. So here, x is in cups. So we would need 8/5 cups of water to mix with 4/5 of a cup of oats. And that makes complete sense if you think about it. Notice that we need 1 cup of water for every half a cup of oats. The amount of water that we need is exactly twice the amount of oats, because 1 is twice 1/2. Since that's our given mixture, we should know then that we need to double the amount of oats to get the right amount of water. Well, if we're using 4/5 of a cup of oats, you double that and we get 8/5 cups of water, which is exactly what we came up with.